Last episode, you built a FAISS flat index and got exact nearest neighbors back in milliseconds, clean, correct, brute force. But brute force scans every vector for every query, and that's fine at 10,000 and a problem at 10 million. So here's the real question. How do you keep search fast when the corpus stops being small? Start with what exact search actually costs. A flat index compares your query to every vector you own, so the work scales linearly with the corpus. Double the data, double the time, no exceptions. At small scale, you never feel it. At production scale, it's the line item that wakes you up. The fix is to stop looking at everything. An approximate index, IVF, carves the space into clusters up front, and at query time it only searches the few clusters nearest your query instead of the whole library. You skip most of the data on purpose. That's where the speed comes from. But skipping data means you might skip the true answer. The vector you wanted could be sitting in a cluster you didn't open, so approximate search can miss. We measure that as recall, the fraction of the true top k you actually got back. Fast and perfect don't coexist here. You're trading one for the other. And the beautiful part is that the trade has a dial, and probe is the number of clusters you search. Turn it up and you recover more of the true neighbors, but pay more time. Turn it down and you fly but lose recall. There's no magic setting, just a curve, and your job is to find the point where recall is high enough and latency still fits the budget. Here's the whole experiment in one file. We make 100,000 vectors, build an exact flat index for ground truth, build an IVF index beside it, then sweep and probe and record recall at 10, and query time at each step. Up top we seed NumPy and generate the data, then build index flat L2, that's our oracle, the exact answers we'll grade everyone against. The key new object is index IVF flat. We hand it a quantizer, the dimension, and analyst door on 24, the number of clusters to carve the space into. IVF is the first FASS index that needs training because it has to learn where the clusters go. So we call index IVF.train on the data before add. Skip the train step and FASS refuses to add. That's the one gotcha that catches everyone the first time. Now the sweep. For each nprobe in the list, we set index IVF.nprobe, time a batch of 1,000 queries, and compare the returned IDs to the flat index's ground truth. The overlap, averaged over queries and divided by k, is recall at 10. Run it. At nprobes for 1, we search a single cluster. Recall at 10 lands near 0.38, so we are missing most of the true neighbors, but it's already about 80 times faster than the flat scan. Turn the dial up and recall climbs fast. By mprobe the 8, it hits a perfect 1.0. Every true neighbor recovered, and it's still roughly 40 times faster than brute force. Every point on the curve beats the exact scan. You just choose how much recall you need. That sweep is exactly what the figure draws. Recall at 10 on one axis, query time on the other, 1 point per nprobe, the curve bending up and to the right. The numbers printed in the terminal are the dots on the card. Same recall, same milliseconds. No rounding away the trade. Pick the knee of that curve and you get near exact answers at a fraction of the cost. That's FAISS at scale. Next episode, we hand the whole index off to a server that does this for you, Weaviate.